Students, today we are going to talk about statistics in poker. This video is inspired by the 2025 SAT examination question 4. And I also made the questions to have the same mark, just alter the contents in it, because I like to play poker. And in a typical exam question, where they give you something you may not be familiar with, they will give you some background information to tell you what the thing is. But basically this paragraph is useless for your question, so you can just ignore it. The actually useful stuff comes from this second one. It says the game of poker that uses a standard 52 card deck. So after seeing this, you may start to thinking about something about probabilities. So it's like 1 in 52 chance or something. And the next one is the rank of single cards from high to low is as this, the normal rank in poker. And the question tells us we also will treat A to J as 14 to 11. And the next part, it says, as the ace is the largest card, a player naturally wants to have an ace in their two initial cards. Now we keep reading the question. A player makes the following assumptions when playing. First, the cards are being dealt at random. This I assume is true for an legal casino. The second one, the probability of getting each number is equally likely. Now this one may not really be true because the number of cards in the deck is limited, but we will assume it's almost true in this question. And the question says, let X represent the number of aces a player has out of the two initial cards. Now when using the assumption stated above, X can be measured using a binomial distribution. Now when you see this, the formulas for binomial distribution should be in your heads now. And the first question says show that EX, that is say the expected value of X, is 2 or 13. So this show that question only one mark, so it's very easy. You just basically plug in the formula. X is binomial distributed with a trial of 2 because there are 2 cards in your hand initially. And then the probability of getting an ace, that's the only part for the 1 mark in this question, is 1 over 13. Because there's 13 different cards from 2 to A. So getting an ace is 1 over 13. And the expected value for a binomial distribution is just NP. So this times this, which if you times together will give you 2 over 13. Next question. Determine the probability of getting at least an ace. This is also 1 mark, so you basically just use a calculator and you can get this. So it's the probability of X, which is number of ace, is greater or equal to 1. So at least an A, 1 ace or 2 aces. To calculate this probability is very easy because it's binomial distribution. You just go to BCD. Lower bound is just 1 because at least 1 ace. And the upper bound is 2 because you only have 2 cards. Number of trials is N is 2 and then P is 1 over 13. After you plug all these numbers in your calculator, you will get this. Next, a player thinks they can raise the number of bets they put down if they can get at least an N in their 2 initial cards. So this person thinks that if they have some big cards in their hand initially, they can just put more money in the table. Using a binomial distribution, the probability of getting at least an N is calculated, obviously by the player, to be 0.4082, corrected to 4 second figures. Determine what card is N. So this question, it tells you it's binomial distribution and also tells you the probability, but it doesn't tell you the P. And so for this question, you know you are going to need some trial and error until you get this value. So you just try. You first recognize that this value is not the same as the last question. So N is not an ace. So try the next option, which is a king. So again, binomial distribution, 2 cards initially. But now the probability of success, that is say, P is 2 over 13. Because you can either get a K or get a A, and in both cases, the player will raise the bet. So in the same trick, you just calculate this probability and you will get this number, which is not the same as this. So you now try next one. Next option is the queen. So now 2 is the same, but now you have 3 over 13 because you have 1 more options now. You can either have a ace, have a king, or have a queen. The 3 options will work out of the 13 different cards. So now you calculate this probability again, which is 0.4082, which is same as this. So this tells you that N is Q, which means the player will raise the bet if they can get at least a queen in their initial cards. Now we enter part B. This is now into the confidence interval and inferential statistics stuff away from binomial distribution. After many losses, the player suspects that the game is not fair. So maybe the player thinks that the card is not being dealt randomly, and the player just kept losing. The player played 100 games, in which only 41 were won. And part 1 is determine the sample proportions in which they won. So for sample proportions, it's very easy. Just number of success divided by the total sample size. The number of success is basically 41 number of games which they will won, and the total sample size is 100. 1 mark, very easy. Just divide these two numbers. And next part, calculate a 95% confidence interval for the population proportion of the games won. And this is 2 marks, but it's actually very easy because whenever a question asks you to calculate a confidence interval, you just go to a calculator, go to this option, 1 probability, Z interval, and your confidence interval will be 95%. Your X numbers, which is the number of success, is 41. Your sample size is 100. And after you enter this into the calculator, you get this. So the 2 marks basically, I think is this 3-second figure is 1 mark, and you need to write a P on the P head. That basically gives you 2 marks. Now the 3 marks in part B before is basically 3 marks because you just either basically copy down the number in the question or use a calculator. But the 2 marks next is now a bit challenging because it says, does the confidence interval calculated in part B2 support the player's suspicions with 95% confidence? Justify your answer. Now you need some justifications now. This type of question, the response may vary, and the answer I provide is no, because the upper bound of the confidence interval is more than 0.5. So if you record, the upper bound is 0.506, and this suggests that the game could still be fair. So you can still have 50 chance of winning. And you therefore cannot say with 95% confidence that the game is unfair. And the reason that the player often loses could be due to the rash decisions made during the game. Now this is something like the justification part, where you add more information to get a 2 mark. So if you remember, if the player get a Q or above in their initial cards, they will add the bet. Now I don't think this is a good strategy for poker, so don't be like that player, or otherwise you'll lose your money. And that's all for today. Mock exam question 4. Thank you guys.